Hello and welcome to another episode from Spiral Physics Education. So this time we're going to be looking at induced charge, and we're going to be looking at a few examples of objects being given an induced charge. So it'd be really helpful for you to know how to give an object static charge by friction and rubbing, and also know that when charges gain electrons they become negatively charged, and when they lose electrons they become positively charged. And also know the law of electrostatics, which is like charges will repel and opposite charges attract. And if you're not sure about any of those, do check out the other video in this topic that's on the channel, and to help you get up to speed with those ideas before we go on to induced charge. Okay, so induced charge. Well, to do an induced charge, you actually need an object to be charged up initially. So we're going to start off with two objects, and we're going to be given the one on the right hand side here, an induced charge. But to do that, we need to charge up another object. So we might have given it a static charge. It doesn't matter how that left hand object has been given a negative charge. It is charged. And what we're going to do is we're going to assume to start off with that this object that we're going to give an induced charge is neutrally charged. So that means it's got the same number of protons and electrons shown by this diagram here. And to start the induced process, we're going to move one of these objects closer to the other. So we're going to move the object we're going to give an induced charge closer to the negatively charged object. And as we do that, the electrons in that object get repelled from the negatively charged object because like charges repel. So all of those electrons in our object have now been repelled to the right hand side. So they've been displaced from their original position. And that's because like charges repel. And what we're going to do, it's still neutrally charged at the moment, so to give it an induced charge, what we're going to do is give these electrons a route down to Earth. And we're going to do that by attaching a wire down to Earth like this. And what the electrons will do is they're still trying to get away from that negatively charged object on the left hand side. So those electrons will then find a route, an easy route, away from that negatively charged object and flow down to Earth. And if we then remove our wire down to Earth, that leaves our right hand side object with a positive charge. So it is now got it's now been positively charged by induction. It's got an induced positive charge rather than a static charge. Static charge would require it to be rubbed to friction to take place and electrons to be stripped that way. This time, in this example, an induced charge because that negatively charged object has caused electrons to move and be displaced. That's what we call induced charge. Okay, so let's have a look at an example that you might have seen in the laboratory where you've had a rod or a comb or something plastic and you've picked up very, very small pieces of paper from the desk. So for example, here we've got a charged comb. So when the comb is charged and you place that comb near a pile of small pieces of paper, the small pieces of paper then get attracted up and stick to the comb. But the small pieces of paper initially are neutrally charged. They have no charge. So let's see how a charged comb can pick up neutrally charged pieces of paper. So if we look at the charge on the comb, so I've only just put the excess negative charge on the comb here. It's obviously got positive charge on there. So this is just the extra charge that's been given by a process, probably friction and static electricity beforehand. So that comb has got an excess of negative charge. But the piece of paper is neutrally charged, so it's got the same number of protons and electrons. And what will happen is that the electrons are going to be repelled away from the piece of paper, maybe onto the far side of the piece of paper or even into the desk, and that is going to leave the piece of paper with an induced positive charge. Now the piece of paper is positively charged and the comb is negatively charged, and what will happen is that opposite charges attract, and that means that if they're oppositely charged and they attract and the piece of paper is light enough, the piece of paper will lift off the ground or lift off the desk and be attracted to the paper. So another and probably more common thing that you've probably done in your past as a child was to stick balloons to a wall. So what we've got here is a balloon that's been given a static charge. It's positively charged in this example, which means when a child has rubbed it on their head or on their jumper, the electrons have been ripped from the balloon, added to their hair or jumper. But this balloon is now positively charged. And what's going to happen is we're going to move the balloon close to the wall, and we'll find that the balloon will stick to the wall. And when it does, the electrons that are near the surface of the wall will get attracted towards the surface of the wall even more. And what happens is the surface of the wall has a negative charge. It has an induced negative charge. The wall itself as a whole is still neutrally charged, but the surface of the wall has a net negative charge. And because the balloon is positively charged and now the surface of the wall is negatively charged, as opposite charges attract, the balloon and the surface of the wall are attracted to each other. And that's another example of an induced charge. And that's really it. It's all about electrons being moved because of another object's charge. So it's very, very different from static charge. And we can give metal objects a charge by this process, by induced charge, as long as they are isolated. And isolated means as long as they're not attached to Earth or you're not actually holding them. So hopefully you found that episode on induced charge useful. Do check out the channel for more episodes on static electricity that are coming up, and subscribe to the channel to check out all the other videos that we've got, and hopefully that will help you improve your understanding of physics and boost those grades for you. And see you next time on Spiral Education Physics. Goodbye.